they are considered to be constants. Okay? To be differentiable, it must also be continuous. So you're basically going to set these two things equal and plug in a 1 to prove continuity. Then to show differentiable, you find the two derivatives and set those equal and plug in a 1. And both things have to happen in order for it to be differentiable. Okay, so here it is again. I'm going to set the two heights equal when x is 1. So plugging in a 1 for x, you'd get this. Okay? Setting their two heights equal. Then I have to find their two derivatives, treating the a and the b like a constant. The two derivatives would be 2ax. If the b is constant, the derivative is 0. Has to equal 6x. Plug in the 1 again. Okay, and these are the two equations that you have to solve for. Okay, so here divide by 2 and a is 3. Plug that back in over here, and you get that b is 0. Okay, so to be differentiable, it has to also be continuous, but not the opposite, not vice versa. Now, if I just said continuous and didn't mention the differentiable part, I have to change the problem a bit. Hold on, let's make that a number. Okay, now if I just said what value of a would make it continuous, just set the two equal and plug in a 1. So plugging in a 1 for the x, you get this. A would have to equal -4. Okay? So to make it continuous, just set the two pieces equal, plug in a 1. But if I say differentiable, you have to do two things. You have to make it continuous and also find their two derivatives and set those equal. Aha! I remembered one more. Okay? They give you this equation, whatever it is, and they ask for the derivative of it. Okay? Write down what you think the answer is. Hit pause. Okay, derivative of the first piece is just 7. The derivative of an integral is the fundamental theorem of calculus part 2. We're doing a derivative of an integral, so they undo each other, and you just get this, but you replace the t with the 2x and multiply by the derivative of that 2x. So this would end up being 2x quantity squared plus 3 and multiply by the derivative of this. Okay? They undo each other, so you just get what's here, replacing the t with the 2x. That's a very common one, okay? Derivative of an integral. And you can simplify that. Let me give you another similar one. Okay, if I asked for this derivative, the derivative and integral undo each other, you would just get x cubed minus 2 times the derivative of x, which is 1. Now, if you want me to show you why it is what it is, I'm going to show you again right now. But you do need to memorize this. Okay, if I ask directly for f prime of x, then the answer should be fundamental theorem of calculus part 2. Replace the t with the 3x, so you get 9x squared, times the derivative of 3x, which is 3. And my answer would just be 27x squared. So we know that that's the answer without any work. Okay, it's just 27x squared. But now let me show you once again why it is what it is. Okay, now that's my answer. I'm going to work this out the long way. I'm first going to actually do the integral. Okay, I'm going to integrate this t squared. And I would get t cubed over 3 evaluated from 1 to 3x. Okay, then I plug in my 3x. 3x cubed would be 27x cubed divided by 3. And I plug in my 1, okay, and I get 9x cubed minus 1/3. That is if I just integrate it, though. That's just the integral. My question is, what's the derivative of this integral? So if I change this so that now I need to get the derivative of this, okay, now the derivative of that would be 27x squared, and the derivative of a constant is 0. Notice, same answer. So if you're asked to do the derivative of an integral, the shortcut is they basically undo each other, but you have to also multiply by that 3x. Okay, so I integrated, this is still f of x right now because it was defined to be an integral. Then I found the derivative of it, and we got that same same answer real fast. Okay? Derivative of an integral. The bottom number has to be a number. The top is a function in terms of x. Replace the t